Hi, I'm Thomas Wilson. I'm a challenge participant, and today we're going to be taking the limit as x approaches 1 of x to the fourth minus 1 all over x squared plus x minus 2 times x squared plus 3x minus 4. Alright, so at first what we notice is that if we were to plug in 1 to this function, because that's always going to be your first step when you're solving for a limit, is just to see what happens if you plug in what x approaches. So if we were to plug in 1, we would get 1 minus 1 all over 1 plus 1 minus 2 all over 1 plus 3 minus 4. So what you would notice is that all of this is equal to 0 over 0. You would get 0 in the numerator because of the 1 minus 1, and then the 1 plus 1 minus 2 is going to be equal to 0, and anything times 0 is 0. So you end up with 0 over 0. And when you're taking limits, 0 over 0 is telling you that you need to do more work. There's something else you could do in order to find out what the limit is. So whenever you have 0 over 0, that is not the answer. So what we need to do is more work. We need to factor out or do something in order to get this into a form in which we can plug in 1 and not get 0 over 0. So we're going to try factoring. So limit as x approaches 1. So factoring out the top, we get x squared plus 1 and x squared minus 1. Okay, and now let's factor out the bottom also. X squared plus x minus 2 is going to be equal to x plus 2, x minus 1. X squared plus 3x minus 4 is going to be equal to x plus 4, x minus 1. Alright, so now we can further simplify the numerator with the x squared minus 1. So then we have x squared plus 1 and x plus 1, x minus 1 all over x plus 2, x minus 1, x plus 4, x minus 1. Alright, now what you should notice is that we can cancel out an x minus 1 from the numerator and x minus 1 from the denominator. Alright, and what we're left with is limit as x approaches 1 of x squared plus 1 times x plus 1 all over x plus 2, x plus 4, and x minus 1. Alright, so now that we've factored and we've eliminated something from the top and bottom, we can try and plug in 1 again and see what we get. As long as we don't get 0 over 0, we know that it's going to be our answer. So, plugging in 1, we get 1 plus 1 all over, multiplied by 1 plus 1 all over 1 plus 2, 1 plus 4 times 1 minus 1. Alright, so in the top we get 1 plus 1 is 2 times 1 plus 1, which is also 2, so we get 4 over 1 plus 2 is 3, 1 plus 4 is 5, and 1 minus 1 is 0. And since anything times 0 is 0, we're left with 4 over 0. And when you're taking limits, if you have a valid number in the top divided by 0, so if I have 4 divided by 0, the answer just does not exist. So, yeah, it does not exist because you can't have 0 in the denominator. If 0 is in the denominator, your answer just does not exist.